Moving on to the next question. If x follows uniform 11, 16, what is the variance of x? Now, as we had done in the previous question, variance x is equal to b minus a squared by 12. Thus, variance x is equal to 16 minus 11 squared by 12. This is actually 5 squared by 12 is equal to 25 by 12 is equal to 2.0833. So option C is the correct answer. Moving on to the next question. The length of time it takes to wait in the queue on registration day at a certain university is uniformly distributed between 10 minutes and 2 hours. So 10 minutes and this 2 hours can be written as 2 into 60 is equal to 120 minutes. What is the variance of the waiting time? So over here x follows uniform 10, 120. Therefore, variance of x is equal to, as we had done in the previous sums, b minus a squared by 12. So actually it is 120 minus 10 squared by 12, which comes out to be 1008.33. Thus option A, that is 1000, which is approximately equal to 1008 minutes squared, is the variance. Remember one thing, that if say that a variable follows a particular unit, then the variance would follow the square of the unit. The next question is, textbooks are sold at a university at an average rate of 3 per hour. What is the probability that it will be less than 15 minutes before the next textbook is sold? Now see, over here in this question, we haven't been given that the textbooks or the waiting time follows which, that is x, follows which distribution. So over here we read the question and we understand that x follows, that is the rate at which textbooks are sold, follows exponential with parameter, or rather let's solve it in a more detailed way. Now x over here is the textbooks and they would follow rather a Poisson distribution. With parameter lambda is equal to 3. Now, the probability that it will be less than 15 minutes before the next textbook is sold. Now, we could consider this 15 minutes to be the waiting time y, and if we know that if a variable x follows Poisson distribution, then the waiting time for that follows exponential distribution with the same parameter, that is lambda is equal to 3. So probability y less than is equal to 15 is actually, now we can use the function which is the CDF of an exponential distribution. Now CDF of an exponential distribution is 1 minus e to the power minus lambda x. So this comes out to be 1 minus e to the power minus 3 into 15. Now see that over here, first we have considered 3 per hour. So, and here it is given 15 by 60 minutes. So we need to convert this into hour as well. So this comes out to be 1 minus e to m minus 3 into 0.25 equal to 1 minus e to the power minus 0.75, which comes out to be 0.5276, that is approximately 0.528. Thus option D is the correct option.